Let's understand hybridization in terms of group. Now, this is a molecule which I have chosen. Now, I'm not concerned with the name of that molecule, but right now, trying to explain hybridization in terms of group. Now, see, this carbon, if we observe, it has got 4 groups attached to it. 1, 2, 3, and 4. So it is sp3 hybridization. So whenever you see 4 groups attached to carbon, you will straight away call it as sp3 hybridization. 1 of S and 3 of P. Fine. Now let's come over here. Now in this case, this is sp2 hybridization. sp2 hybridization means what? 1 plus 2. That is 3 groups should be attached to that carbon. Now when we observe this carbon, yes, it has 3 groups attached. This is one group, this is one group, and this yet is another one group. Alright, so that's the reason why it is sp2 hybridization. Alright, so we know in terms of bond, we know it is single bond, double bond, and triple bond, but I'm just trying to explain over here in terms of groups. Now when we come to this, now this is this carbon as well as this carbon, both are sp hybridization. Now if they are sp hybridization, then 2 groups, one of S2 and one of P, one of S and one of P. So 2 groups have to be attached. So yes, if you observe here, this entire thing is one group attached. And again, if you observe this side, this is yet another one group attached. So there are 2 groups. So to this carbon are attached 2 groups. So sp hybridization. Now similarly over here also we have sp hybridization, and here we have sp3 hybridization because of 1, 2, 3, 4 groups attached. So this is just a way to explain hybridization in terms of group. Otherwise, we obviously know in terms of carbon, it always is single bond, double bond, and triple bond. Fine. Now let's understand the effect of hybridization on acidity of a molecule. Now prior to getting into it, we have got to understand what does acidity actually mean. Now for understanding it, let's get into here. Now this is acetic acid, which dissociates into acetate ion and H plus ion. This is hydrochloric acid, which dissociates into H plus and Cl minus. Now both are acid. What's the difference? Now this, if you put it in water, it dissociates very weakly. Less of H ion would be there. Whereas if you put this into water, it would instantly dissociate and give you entire H plus ion, whatever is present over here. So this is what is called as strong acid. This is what is called as weak acid. Alright, so it's all based on hydrogen ion concentration in solution. In a solution with acetic acid in it, the hydrogen ion concentration would be very low. In a solution with hydrochloric acid in it, would have very high hydrogen ion concentration. Alright, so that is what is meant by weak acid and strong acid. Weak acid normally we represent it with forward backward arrow, whereas in case of strong acid we represent it by forward arrow because it dissociates and then again comes back. There's an equilibrium here. Alright, whereas this dissociates completely. Alright, that's all about weak acid and strong acid. Now let us get into our topic. In case of sp3 hybridization, ratio of S to P is 1:4. Why 1:4? Because it is 1 of S and total is 1 plus 3, 4. Alright, so 1:4 is the relationship. Whereas in case of sp2 hybridization, the relationship of S orbital to total is 1 plus 2, that is 3. So the ratio is 1:3. Similar in case of sp hybridization, it is 1:2. Alright, it is 1:2. So if we calculate percentage as per 1:4, the percentage of S would be 25%, whereas in this for 1:3, the percentage would be 33.33%, and for 1:2, the percentage would be 50%. Now these are all percentage of S contribution in total. All right. And what we observe is whenever it is sp hybridization, the contribution of S is the most and it is most acidic. Least acidic is with 25% of S contribution and most acidic is with 50% S contribution. Alright, so as the contribution of S increases, the acidity of molecule also increases. So hybridization is also concerned with acidity. sp hybridization most acidic, sp3 hybridization least acidic. Alright, so this is the relationship which you have got to keep in mind. Greater than in terms of acidity. Alright.